Hey everyone, and welcome to this explainer, where we're investigating the hidden engineering that keeps you safe at 30,000 feet. You know, when you step onto a modern airliner, you're literally surrounded by thousands of meticulously designed components. You probably notice the legroom, or the size of the overhead bins, maybe the in-flight entertainment screen. But right behind that aesthetic appeal of the cabin is this entire world of rigorous scientific testing. So today, we're going to unpack one of the most absolutely crucial yet completely invisible safety protocols in modern aviation.
Now, if you're really into aviation engineering, you've probably wondered at some point, why doesn't a seat cushion or a sidewall panel or an insulation blanket just immediately catch fire inside an aircraft? Because the reality is, commercial airplanes are highly complex machines. They're packed with passengers, cargo, this massive network of electronics, and honestly, they're full of hidden dangers. The answer to this actually lies in a series of incredibly strict flammability tests required by global aviation authorities, like the FAA and EASA.
Okay, let's dive right into this and look at the myriad of ignition sources inside a cabin that could threaten passenger safety. Inside an aircraft, you've got hundreds of different materials: seat covers, ceiling panels, lavatory parts, composite interior panels, and literally any of them could be exposed to a spark. We're talking about hidden electrical faults buried deep within the wiring or equipment that just suddenly overheats. Think about the galley appliances where your in-flight meals are prepped. Those ovens generate intense heat. Heck, even routine maintenance activities can accidentally introduce fire risks. The sheer number of potential ignition sources means that simply hoping a fire doesn't start, that isn't a viable safety strategy.
So what does this all mean? Well, that brings us to the core philosophy of aircraft interior design. The ultimate goal of aviation fire safety actually isn't creating a cabin that is 100% fireproof. Scientifically speaking, with the lightweight materials you need for flight, that's practically impossible. Instead, the real goal is to resist flame spread to buy precious time for passenger evacuation. Every single second counts in an emergency. The engineering is entirely focused on delaying the fire, ensuring that if a spark does happen, it doesn't instantly flash over and consume the whole cabin before the pilots can land and everyone can get out safely. To make absolutely sure materials won't rapidly spread fire, engineers rely on a very specific, rigorous laboratory mechanism, the 60-second vertical Bunsen burner flammability test. This is a mandatory certification hurdle under FAA 14 CFR Part 25 and EASA CS 25 regulations. And instead of just checking if a material burns, this specific test evaluates exactly how a vertically mounted material behaves when it's exposed to a direct, localized flame for exactly 1 minute. It measures whether the material self-extinguishes, if it limits the spread of the flame, and crucially, if it prevents the fire from propagating further. Manufacturers absolutely must pass this before any material can even get close to being installed on a transport category aircraft.
Now, to actually achieve certification, the testing environment has to be flawlessly controlled. You can't just take a lighter to a piece of fabric in a parking lot, right? The regulations outline a highly precise laboratory setup. You need a specialized vertical specimen holder to keep the material perfectly aligned. You need a laboratory-grade Bunsen burner fueled by specific gases like methane or natural gas. The flame height is strictly controlled. You need a precise stopwatch, a measurement scale, and, this is a big one, a totally draft-free test chamber. Even the slightest breeze in the room could alter the behavior of the flame and completely invalidate the results. The burner is positioned precisely beneath the lower edge of the mounted specimen.
60 seconds. That is the exact time frame the material is subjected to the continuous, intense flame of the Bunsen burner. 1 minute might sound brief, but when a highly engineered aerospace component is suspended directly over a roaring, concentrated flame, 60 seconds is a brutal, unforgiving trial by fire. It's designed specifically to simulate a severe localized ignition event.
The methodology here is almost ruthless. After the material specimens are cut to exact regulatory dimensions, and they actually test several of them to ensure absolute repeatability, they're mounted perfectly vertically. The burner is dialed into a mathematically precise flame height, positioned directly beneath the specimen, and applied continuously. For exactly 60 seconds, the material literally bakes. And the moment that burner is pulled away, the real scrutiny begins, and engineers have to immediately begin their measurements. There is absolutely zero room for error here.
Once the heat is gone, engineers watch the clock. They're looking to see, does the material continue to burn, that's the afterflame time, or does it silently smolder in an afterglow? They measure the burn length to see exactly how far the damage traveled upward. But the ultimate killer in this test is flaming drips. If molten burning material drips off the specimen, it could easily ignite the cabin floor. A single flaming drip can mean an instant failure. And let me tell you, getting a passing grade is incredibly difficult. Materials fail all the time during research and development. They fail because they continue burning way too long after the flame is removed, or they melt excessively into dangerous puddles. They fail because they produce those terrifying flaming droplets we just talked about, or the burn length travels too far up the fabric. Often the base fabric itself is totally fine, but it fails because of unsuitable resin or adhesive systems that are used to bind the layers together, or honestly, simply due to inconsistent manufacturing quality. Here is what you really need to understand about aircraft safety. Even a minuscule change to a material's manufacturing process means the whole component must undergo repeat certification testing. You literally cannot just change the dye color of a seat fabric without re-verifying its flammability.
Practical aircraft scenarios. Moving from the lab to the cabin. Okay, imagine you're settling into your seat, and a passenger nearby accidentally drops a lighter and it sparks against the seat cushion cover. Because of the materials used in the cabin environment, the fabric might briefly ignite. But here is the absolutely critical part. If that seat cover was certified correctly under the 60-second test, the flames will extinguish almost immediately on their own. The fire doesn't spread to the foam beneath, and the surrounding seats remain completely protected. What could have been a disaster becomes nothing more than a minor incident. Or consider a second scenario. Deep behind the plastic walls, right next to your window, an electrical short occurs. This creates a localized, really intense flame against the sidewall composite panel. Now, a non-compliant panel would ignite, rapidly spread the flames straight up the wall, and release deadly heat and toxic smoke right into the cabin. But a compliant, certified panel? It will fiercely resist that flame spread, it actively limits the heat release, eventually extinguishes itself once the initial spark dies down, and successfully protects the critical cabin systems hidden your way. Here's a third, and honestly very critical scenario. Aircraft fuselages are lined with these thick insulation blankets to keep you warm at high altitudes. Imagine one of these blankets, installed behind the cabin panels, is exposed to intense heat from a hidden electrical wiring fault. Because this specific blanket has passed the 60-second vertical flammability test, it intensely resists sustained burning. It prevents a hidden, structural fire from rapidly spreading through the dark spaces of the fuselage. And most importantly, it gives the flight crew vital time to actually detect the smoke, isolate the electrical problem, and respond to the emergency.
So the absolutely crucial takeaway here is that out of the thousands upon thousands of certified interior components on a modern airliner, every single approved material has undergone this extensive fire testing before ever entering service. The 60-second vertical Bunsen burner test isn't just bureaucratic red tape, folks. It ultimately serves one profound purpose: buying time. By ensuring that the aircraft interior actively slows the spread of fire, engineering vastly improves survivability and enables the flight crew to execute a safe emergency evacuation. It is, quite literally, the science of saving lives.
Which brings us to the end of this explainer on aviation safety. The FAA and EASA standards are unforgiving for a very good reason. By constantly measuring after flame time, burn length, and flaming drips, engineers really hold the line on safety. So next time you board a plane, as you walk down that aisle and stow your bags, take a look around you. Which of the thousands of certified fire-resistant components are you going to notice first? The ceiling panels? The carpet? The seat you're sitting on? They are all silent guardians, tested by fire, to ensure you arrive safely at your destination. Thanks for joining me on this explainer, and keep your curiosity soaring.